Hey, congratulations! You've made it to chapter 6. In fact, 6.1 Properties of Square Roots. Now, we might have seen square roots as we've went along so far this year, but we're really going to learn about how we deal with them in a multitude of different ways. The first two ways, mainly, are going to be with the product property, which is this guy, and the quotient property, this guy. Beautiful. Now, how do we express the product property, very formal term, using algebra? Well, what the product property is that if I have the square root of something, multiplying, it's another word for product, the square root of something else, then that's the exact same thing as the square root of both of those things multiplied together underneath one square root. Seems pretty simple, right? So let's take a look at how that works with some numbers. Let's say that I have the square root of 9 times 5, also known as the square root of 45. Then that should be the exact same thing, since it's 9 times 5 underneath the square root. I should be able to split it up to be the square root of 9 times the square root of 5. Now, why is that helpful? Because I actually know the square root of 9. The square root of 9 is 3. The square root of 5, I don't know. So it's 3 times the square root of 5, or as we like to say, 3 square roots of 5. Alright, now let's look at the quotient property. The quotient property says mainly the same thing, but using division. It says that if I have the square root of some fraction, x over y, then that's the same thing as the square root of the numerator over the square root of the denominator. So the square root of the top or the square root of the bottom. Now let's see what that looks like in number form. If I have the square root of 3/4, how am I going to try and find the square root of a fraction? Well, our property says that that should be the same thing as the square root of 3 over the square root of 4. Why is that good? Well, because I actually know what the square root of 4 is. Square root of 3, not so much. So I have the square root of 3 over the square root of 4 is 2. Beautiful. Now let's do a couple of problems, and let's put these to good use. Example 1, we're just going to be simplifying. Now, how am I supposed to take the square root of 150? I don't know what the square root of 150 is. Maybe I know what the square root of 100 is, right? Because it's just 10 times 10, so the square root of 100 would be 10. But 150, not so much. So we try to use something like the product property to simplify it a little bit. Are there two numbers that multiply to 150 that I could maybe break it up like I did with the square root of 45 up here? I broke it up into 9 times 5. I think if I, really rack my brain, I might be able to come up with 25 times 6. Now, what's so special about choosing 25 times 6? Because there are other numbers that multiply to 150, like 15 and 10. But why am I not using 15 and 10? Why am I not doing the square root of 15 times 10? The reason I'm not doing that is because I still don't know the square root of either 15 or 10. The good thing about 25 and 6 is that when I split it to the square root of 25 times the square root of 6, I actually know the square root of 25. It's 5, which leaves me to just multiply that by the square root of 6, and I have a simplified version, 5 square roots of 6. This one's not going to work. I don't know the square root of 15 or 10. Now let's look at B. If I have the square root of this horrendous fraction, 15 over 64, how am I supposed to find the square root of that, or at least simplify it? Well, quotient property tells me I can take the square root of the top, square root of 15, over the square root of the bottom, 64. And do I know the square roots of either of these? Well, the numerator not so much, square root of 15. The denominator, though, square root of 64, that I do know. Ocho, also known as 8. Alrighty, now let's go to example 2. Example 2 looks like it's going to be pretty complex. Evaluate square root of b squared minus 4ac for each. So I have an a value, I have a b value, and I have a c value. It's going to go all in here. Okie dokie. Square root of b, negative 8 squared, minus 4 times a here is a 2, times c is a 4. Alrighty. Now when I evaluate this, what is it that I'm going to get? I'm going to get a 64 over here. I'm going to get 4 times 2, so that's 16 times 2, which is 32, all with a negative sign in front of it. And 64 minus 32, you got it, 32. So now I have to worry about how do I simplify the square root of 32? Well, are there two numbers that I can split 32 into? One of which I would know the square root of. Well, how do I get to 32? Maybe I could do 8 times 4, but I don't know the square roots of 8 or 4. Or maybe I could do 16 times 2. That's another way of making 32. And I know the square root of 16. So the square root of 16 times the square root of 2. I know the square root of 16 is 4, but I don't know the square root of 2. That's as simplified as I can go. Now let's look at part B. I'm going to evaluate again square root of b squared, in this case it's a negative 6, squared minus 4 times a, which is a 2, times c, which is a negative 5. Okie dokie. Let's see, negative 6 squared, 36. Negative 4 times 2 times negative 5, that's going to be 40 plus 40. What is 36 plus 40? 76. What? This is craziness. So, what am I looking for when I get this value? Got it. Now this might be difficult, but 76 can get broken up into two different numbers that multiply, and one of them is a square root. Might take a little bit of time, but you can get 19 times 4. Alright, now do we know the square root of either of these two numbers? We do. We know the square root of 4. The square root of 19 times the square root of 4. The square root of 4 is a 2. 2 times the square root of 19, which we like to write this way, 2 square roots of 19. Done and done. Alright, we have 2 more problems to do, and it's just about trying to simplify expressions now. If I have 6 plus the square root of 8 over 2, how could I possibly simplify this even more? I know that the 2 is dividing 6, which should be easy. 2 goes into 6 3 times. But how am I supposed to divide the square root of 8 by 2? Because the 2 is not just dividing the 6, the 2 is also dividing square root of 8. I wonder if there's a way that I can rewrite the square root of 8 so that it looks nicer, so that I can simplify. Well, 8 can also be written like 2 times 4. So the square root of 8 equals the square root of 2 times the square root of 4. Interesting. I know the square root of 4, so this is the same thing as 2 square roots of 2. What if I rewrote this? So it said 6 plus 2 square roots of 2 over 2. I still can do 6 divided by 2, which is 3, but now I see I have 2 square roots of 2 divided by 2. That 2 divided by 2 is just a 1, so I have plus the square root of 2. Very, very cool. It's all about trying to make the numbers look nicer or look so that I can simplify. Let's try and do part B. This looks like it's going to be a bit more difficult. Alright, let's try and deal with this square root first, because that seemed to be what I needed to do over here. I changed the 8 to something else. So let me see if I can change the 27 into a different number to simplify it. Well, the only way I can really think to simplify 27 would be something like 9 times 3. So I'm going to change this so it says negative 1 minus the square root of 9 times the square root of 3, all over 4 still. So 27 has been changed into 9 times 3. I know the square root of 9, so I'm going to change this again. Negative 1 minus square root of 9 is a 3 times the square root of 3 over 4. Can I change it any more than that? No. I could write it separately, negative a fourth minus 3/4 times the square root of 3, but I don't need to. This is as simplified as it's going to get. Awesome. I know that some of this stuff can be confusing, and it requires you to really think and know your factors and to be able to kind of think a couple steps ahead. But try your absolute best with this. It's going to take some time to get used to and to get really, really good at, but it's really, really fun and interesting once you get the hang of it. All right, so try the problems. Write down any questions that you have. We will talk about it in class, and fare thee well.